Welcome to solverfy.
This question we have to find the slope at point A and the deflection at point C. So from the diagram, we can draw the fluidity diagram and we can get the m1 and m2 as a function of x1 and x2. So m1 is px1, m2 is pl divided by 2. And from the elastic curve and slope equations, we can have that ei d square v1 by dx1 square is equal to mx1, which is px1. And if we integrate that, we can have that ei dv1 by dx1 is px1 square divided by 2 plus c1, and if we integrate it further, we can have that px1 to the power of 3 divided by 6 plus c1 x1 plus c2. I will give this equation 1, and this will be equation 2. And from mx2, you can have that ei d square v2 by dx2 square is pl over 2, and we integrate that, we can have ei dv2 by dx2 is pl over 2 x2 plus c3, and el x2 will be pl divided by 4 x2 square plus c3 x2 plus c4. And this is equation 3, this is equation 4. And from the boundary condition, at x1 equal to 0, v1 equal to 0, we take that in equation 2, you can have that c2 is 0. And at x2 equal to 0, we have that dv2 by dx2 equal to 0, and if we take that in equation 4, equation 3, we have that c3 is 0. And from these two continuity condition, at x1 and x2 equal L over 2, v1 equals v2, and dv1 by dx1 equals minus dv2 by dx2. So from these two conditions, we can have c1, which is minus 3 over 8 pl square, and c4, which is minus 11 divided by 48 pl to the power of 3. And so at point A, which is at x1 equal to 0, I have that dv1 by dx1 equal to sigma A, and that is minus 3 8 pl square by ei. From the first equation, that is the first answer. And at x1 equal L over 2, we can have vc, which is p times L over 2 to the power of 3 divided by 6 ei minus 3 over 8 ei pl to the power of 3 times L divided by 2 plus 0, and that is minus pl to the power of 3 divided by 6 ei. And these are the answers.